In this example, we're asked to compute several probabilities given this table of values. So if you haven't already, pause the video to take a moment and read the full problem statement. Also note that we do know there's a total number of people represented in this table, and that value is given up here. So what I did was I just copied that same table over here to a slideshow so we can work with the values that are in it. The first thing I want to do is go ahead and calculate some totals. So I went ahead and calculated the total of all of the people who died from cancer and all of the people who did not die from cancer by just simply adding up the values in each column. Next, I found a total within each row. So this value here is the total number of people who never smoke cigars, and so forth and so on. So I add up through the rows and I get that total. If I add up either of these total columns, I also come up with the total number of people surveyed, and that matches the problem statement originally. So that's a good check. So next we have our questions that we were asked, these different probabilities we were asked to compute. The first one was the probability that someone died from cancer. To calculate that probability, we would need to know all the numbers of people who died from cancer, so that's where this total comes in, divided by the total number of people represented in the table. So the part divided by the whole, think of it that way. Next, we were asked about the probability that someone is a current cigar smoker. So I noticed that is through a row, this row here, current cigar smoker. I find the total number of people who are a current cigar smoker and divide by the total number of people altogether in the table and can come up with that probability. And the next one is looking for an intersection of two values, or two events rather. This is the probability that someone died from cancer and they are a current cigar smoker. So in that case, I'm looking for one particular cell within the table. Notice that 136 represents the number of people who are a current cigar smoker and died from cancer. I will then divide that by the total number of people to arrive at this probability. Probably up to this point, these are fairly straightforward probabilities. The last one is asking about an OR probability. So since the last one's asking for OR, died from cancer or current cigar smoker, we can use the general addition rule. So I've just copied here the general addition rule, which states that the probability of event A or B is the same as the probability of A plus the probability of B minus the probability of A and B. Relating that back to our given scenario, I guess you could say, or the context of this problem, again, we're looking for the probability that someone's died from cancer or is a current cigar smoker, given this data in the chart. If we break that apart with the general addition rule and apply our context, that's the same as the probability of dying from cancer plus the probability of being a cigar smoker minus the intersection of the two, the probability of dying from cancer and being a current cigar smoker. Since we've already calculated these things, we could look at this as simply take the answer to part A, add the answer to part B, and subtract the answer from part C. Notice those three pieces here were kind of setting you up to use this general addition rule in part D. To further illustrate the reason why we subtract that intersection, I'm highlighting here, this is the total of all the people dying from cancer. That helps us get this probability that we see here. Next, we see the total of all the people who are current cigar smokers. Again, that helps us get the probability that we saw here, like what we saw earlier in part B. And then what we're subtracting is where those two overlap, because otherwise we would count these 136 people twice. And we would not want to do that, so we'd have to subtract that intersection to arrive at the probability of A or B only.